This lesson will explain under what circumstances the addition of temporary ballast might be needed and how to determine how much ballast is needed. Additional information on this topic can be found in the FAA General Handbook 8083-30, Chapter 4, and in the Aircraft Weight and Balance Handbook. If an aircraft has been loaded in such a manner that its loaded center of gravity is outside of the center of gravity envelope, it may be necessary to add temporary ballast to bring the aircraft back into the allowable center of gravity range. The formula for determining how much ballast must be added to bring the loaded center of gravity back within allowable limits is ballast weight equals the product of the aircraft weight and its distance out of limits divided by the distance between the ballast and the desired CG. We can use this sketch to better explain how to use this formula to determine how much ballast is needed to bring this aircraft into balance. This red line here is our forward CG limit. This blue line here represents our aft CG limit. This purple line and box represents the location we will add ballast to bring this airplane back into balance. This green line represents our current as loaded center of gravity, which needs to be brought back within the center of gravity envelope. It's our desire to bring it back just inside the center of gravity envelope, because the further we bring it back, the more weight we have to add to the ballast location and the more weight the plane has to carry. Our formula describes two distances: the distance out of limits, which is this distance here, the distance between our as loaded CG and the closest place within the center of gravity range, and the distance between the ballast and the desired CG, which is the distance between our ballast location and the closest place again in our center of gravity range. These ballast problems can be thought of like the lever problems we solved earlier in this class, where here we can have the aircraft weight, the distance between it and the fulcrum, which we'll think of as the forward CG limit, is the distance out of limits. The distance our as loaded CG is between it and the closest place within the CG limits. In this box, our ballast location and the distance from it to, again, the closest place in the CG limits. Let's work a ballast problem where the as-loaded center of gravity is ahead of the forward center of gravity limit. In this example, the aircraft weight is 1,045 pounds, the as-loaded center of gravity is at 10 inches, and the allowable center of gravity range is from 12 inches to 14.5 inches. The ballast arm, or the location where the ballast is to be placed to bring the as-loaded center of gravity back within the allowable limits, is 48 inches. Input these values into our formula to determine how much ballast needs to be added. Begin with the aircraft weight, which is 1,045 pounds, and multiply this by the distance the center of gravity is out of limits. The forward center of gravity limit is 12 inches, and the as-loaded center of gravity is 10 inches. Therefore, the distance the aircraft center of gravity is out of limits is 12 inches minus 10 inches, or 2 inches. Divide this by the distance between the ballast location and the desired center of gravity. The desired center of gravity location is the closest point within the center of gravity range to the as-loaded center of gravity. In this example, that is 12 inches. Therefore, we have 48 inches minus 12 inches, or 36 inches, as the distance between the ballast location and the desired CG. Once we have performed these calculations, we discovered that we must have 58.06 pounds of weight at the ballast location to bring the as-loaded center of gravity of this aircraft back within the allowable center of gravity limits. We might also find situations where the as-loaded center of gravity is behind the aft CG limit. We solve these problems just as we did in the previous example where our as-loaded CG was ahead of the forward limit. The difference being, in this instance, that our distance out of limits is the distance between the as-loaded CG and the aft CG limit, whereas the distance between our ballast and the desired CG is the distance between our ballast location and the aft CG limit. In this example, we're going to determine how much ballast we need to add to bring the as-loaded center of gravity back into the allowable center of gravity range when the as-loaded center of gravity is behind the aft CG limit. Let's start with an aircraft weight of 1,165 pounds. The as-loaded center of gravity is 110 inches aft of the datum. The allowable center of gravity range is from 76 to 104.5 inches, and the location where we're going to add the ballast to balance this airplane is 21 inches aft of the datum. We'll start back with our formula. Ballast weight equals the aircraft weight times the distance out of limits divided by the distance between the ballast and the desired CG. We'll first add the weight of our aircraft, 1,165 pounds, and multiply this by the distance out of limits, or the distance between our as-loaded center of gravity and our aft CG limit, 110 inches minus 104.5 inches. We will divide this by the distance between the ballast and the desired CG, our ballast location of our ballast location of 21 inches, and our aft CG limit of 104.5 inches. Once I perform these calculations, we will discover that we need to add 76.74 pounds of ballast to our ballast location to balance this aircraft or to bring its as-loaded center of gravity back into the allowable range.